Hello guys, in today's video we are going to discuss the solution of the problem sorted insert for circular linked list. So let us look at the problem statement. So the problem statement says that we are given a sorted circular linked list of length n. The task is to insert a new node in the circular linked list so that it remains a sorted linked list. So a linked list is given to us. So for instance, this linked list is given to us and this is a circular linked list. And what we have to do is that we need to insert an element into this particular linked list. So in this particular case, 2 needs to be inserted in this linked list. So the resultant linked list will be something like this. Okay. Similarly, 5 has to be inserted in this linked list. Then the linked list after insertion, it should be sorted. So the linked list is sorted, and then after insertion, the linked list must be sorted. So this will be our resultant linked list. So let us look at the solution for this. So in this particular case, what will happen is there will be multiple cases which could happen, and depending upon these multiple cases, we have to perform insertion. So let us discuss the various cases which could arise here. So the first case could be linked list is empty, right? It might be possible that the linked list is empty. So in that particular case, the node will be our the starting node, and we have to return it. We will see how we are going to handle this particular case. The second case is it might be possible that the linked list contains just one node, contains one node. The third case is possible is basically linked list contains multiple nodes, but the insertion needs to happen at the beginning. The fourth and final case is otherwise, right? So if all these cases does not satisfy, then the final case, which will be case 4, which we will handle it. So now let us look at how we are going to code for all these cases. So remember, the first case is when linked list is empty, right? So when the linked list is empty, what we are going to do is, so first we will have our temp node prepare. So temp node will be is equals to node and then the data, right? So this is the node which we want to insert, and we know that head is none because the linked list is empty. So what we will do in that particular case, if so we will first check whether this condition is satisfied or not. So this condition will be satisfied if head is equals to none, right? Head is null. Then we know that the linked list is empty. In that particular case, what we are going to do is we are going to say head is equals to temp. Okay, temp dot next is equals to head. So what we did is basically initially the linked list was empty. So let me represent empty by this. We had a temp node with us. Let us say this temp node is with us and it contains some data. Let's say that data is X, and right now the next part is none. So what we did is this is our temp. So the first line ensures that head becomes temp, right? So the head which was empty, this is this, now head becomes this, and now this portion which was empty will point to itself, right? Temp dot next is equals to head is something which points to itself, right? So with after doing that, we are going to return head, right? So this is how we will be able to handle the first case. Now let us look at the second case. So the second case was what? Let's look up. The second case was linked list contains only one node. So let me write it as CLL, circular linked list contains just one node. Okay, so since it contains just one node, so the linked list will be something like this, right? And since it contains just one node and it is a circular linked list, so this is what it will be, and this is where our head is, right? So let us see how we are going to do it. Now it might be possible that the node which needs to be inserted is this, right? So this is our temp node which we want to insert. So here, since this is 1 is less than 2, so 1 needs to be inserted here. So let's address that. So let us first write the case condition which understands that it contains just one node. And how do we know that the linked list contains just one node? Well, if it contains one node, then the head will be equals to the next of head. So head is equals to head of next, and that is how we know that the linked list contains just one node. Now once it contains just one node, we are going to check if temp dot data is less than head dot data. If this condition is satisfied, then we need to insert temp at the beginning of the linked list. So here we need to add the temp. So our temp will be something like this. So in order to do this, what we have to do, first the temp next should point to head, right? So let us write it down. So temp of next should point to head, right? So let's make this arrow, right? This points to head, and this portion which was pointing to itself, right, this, we have to get rid of this, and we have to say that this points to this, and head which was pointing here should be here, right? So let us make it first. The next, let us arrange it such that it points to the starting. So here we have to write down head dot next is equals to temp. So this, by this line we have removed this and we have moved this to this, right? And now what we need to do is that we need to move this head to here. So let us move that. Now head is equals to temp. So now let us look at the case where this condition is not satisfied. So let's say that our linked list initially contains this, right? And the element, I'm so sorry, this is not cross. Let me just get rid of this. This is rather this, right? The linked list is this, and we want to insert 3 to this linked list, right? So in order to insert this 3, so this is our head at this point of time, and this is our temp. So what we are going to do is, first we are going to say that this, let's break this. So this is head of next, which was pointing to itself, will now point to the next node, which is equals to temp. Okay. Once we have done that, now what we need to do is that we need to make this next points to head, right? So temp dot next is equals to head, and head we don't have to change here because head already head is already pointing to the beginning of the linked list. So this is what it is for case 2, and once these two conditions are satisfied or we have gone through it, then we are going to return head. So this is our condition 2 or case 2. Now let us look at the third test case, or the third. So let us look at our third case where linked list contains multiple nodes, but the insertion needs to happen at the beginning. So let's look at that. So this is our third case. Multiple node in circular linked list, but insert at beginning. So first let us see if we want to insert at beginning of the linked list, then this condition must be satisfied. Then the temp dot data should be less than head dot data. Then only we have to insert at the beginning of the linked list. Now if this condition is satisfied, then what we have to do here is we have to So first, let us take an example for this. So let us say, you know, right now our linked list is something like this, right? And it contains some values like 1, 2, and 3. Okay, and this, since this is a circular linked list, it is something like this. And now we want to insert 0 to it, right? So that's the case. So what we want to do here is, the first thing which we want to do is we want to make this connection. So let us make this connection. So this is basically temp dot next is equals to head. Once we have made this connection, the second thing which we want to do is we want to now make this the last node points to, so this we need to get rid of, and we want to make this connection, right? So in order to make this connection, first we need to get to the last node of the linked list. So let us see this. So what we are going to say is last is equals to none. Okay, and we are going to say that there is a ptr variable, and ptr is equals to head of next. And what we are going to say is while ptr is not equals to head. Okay, while this is not equals to head, we are going to do this last is equals to ptr, and ptr is equals to ptr of next, right? In this way we will be able to find the last node. So the last node will be there in this variable, right? The last node will be there in this variable. So once we get the last node, we need to do is, what we need to do is this portion, right? So now this should point to the last node, should point to temp, right? And once we have done this, remember right now the head is here, so we have to move this head to this position, right? So what we need to do is head is equals to temp. So we have moved our head also, and once all these conditions are done, we are going to return head. Okay, so that is how we are going to tackle the third case. And if all these cases, if these three cases, the first three cases are not satisfied, then we have to handle the fourth case, which is our final case, which is basically we want to insert an element in a multi-node linked list, right? So let us say, so this is our multi-node linked list, and right now it is something like this, and we want to insert an element in this linked list, right? So let us say this is the node. So right now the head is here, right? And this is the temp which we want to insert, right? So what we will do is basically, in order to insert this, what we are going to do is we are going to find a previous, or the element after which the temp needs to be inserted. So let us say, let's just take an example, 1, 2, and 4, right? And let us say this is 3. So after 2, so in this particular case we need to find this position, right? Because after 2 we have to insert 3, right? So let us see how we are going to find this position first, right? This position after which the insertion needs to happen. So in order to find that, what we are going to do is, basically what we are going to do is we are going to have a variable ptr, and we will say ptr is equals to head of next, right? And we will have some previous variable, and previous is equals to head, right? So ptr points to the element next to head, and the previous of next to head is head itself. And then we are going to say while ptr is not equals to head, and ptr dot data is less than temp dot data, right? And then what we are going to do is previous is equals to ptr, right? And ptr is equals to ptr of next of ptr, right? And the previous pointer, right, this pointer will contain the info or the node after which we need to insert temp, right? So now we have previous with us. Now after that we need to insert temp. So let us insert it. Previous dot next is equals to temp, right? And temp dot next is equals to ptr, right? So we need to know, so let us take this example. We need to know these two. What we have to do is we have to cut down this. We have to do this, right? So this is my previous and this is my PTR. So previous of next becomes this. And once we have done this, we have to say temp of next becomes PTR. So that is what we have we wrote here. Temp dot next becomes equals to PTR. And once we have done that, we are going to return head. Okay. By the way, this also covers the case where we want to insert an element towards the end, right? After, so let us say the linked list is something like this. Let me just have it like this. Okay. So let's say this is 1, this is 2, this is 3, and we want to insert this. Okay, let's just have it like this. So this is our initial linked list and we want to insert 4 into this circular linked list. So as per algorithm, what will happen? This will be our previous, right? And this will be our PTR. So what we have to do here now, previous dot next is equals to temp. So let us do that. So previous dot next, right? Previous dot next is equals to temp. So this is now gone and this translates to this. And what we have to do is temp dot next, and remember this is our temp. Temp dot next is equals to PTR. So this, right? So using this, we will be able to insert or cover the final case. So that's about the explanation, folks. Now let us jump to the coding section and code it out. So I've already coded it. Now let's go to the code. So the first case is this, case 1, when the head is none, and which is basically the linked list is empty. So if head is equals to none, then we will insert head equals to temp, temp dot next equals to temp, which is essentially making it circular, and then return head. If linked list, this is case 2, if linked list contains just one node. In the case it just contains one node, so that will be given by this condition. It contains just one node. Now if the temp needs to be inserted at the beginning of the linked list, then this is the code for it. We have already discussed it. If temp needs to be inserted at the end of the linked list, then this is how we are going to insert it. Once we have inserted it, then we are going to return head. Okay. Now the third case, where the linked list contains multiple nodes but temp needs to be inserted at the beginning. So since we need to insert, so this is how we are going to find out if temp needs to be inserted at the beginning, then this condition will be satisfied, and then we will say temp dot next is equals to head. So we have inserted it at the beginning. Now once we have inserted it at the beginning, we have to move head to temp. And also we have to make the linked list circular. So the last node now should point to temp. So let's see how we are doing that. So the first thing which we do is that we found out the last node, and this is how you find out the last node. Once you have the last node, then the last node dot next becomes equals to temp, and let us move our head to temp, right? And then we return head. And if all these three conditions are not satisfied, then the final case, which is we want to insert in a linked list, in a circular linked list. So PTR equals to head of next. So we find out PTR and previous by this logic. Once we have find it out, then we say previous dot next equals to temp, temp dot next is equals to PTR, and towards the end I return head. So that's the code for it, folks. Now let us submit our solution. So our solution got accepted. So that's from this video, folks. In case if you have any questions or query regarding this video, please feel free to use the comment section and I will try to address them. Thank you.